Here's our overview for Mission 1, Lesson 11. Our student objective for this lesson states that we should be able to use place value understanding to fluently add multi-digit whole numbers using the standard addition algorithm and apply the algorithm to solve word problems using tape diagrams. That is a wordier way of saying we need to be able to add. Essentially, that's what it's saying. We need to be able to do long addition problems. So using the standard algorithm is just a standard equation and solve them. Okay. And then be able to set up a tape diagram to do word problems with that. So if we can add, then that's our goal for this. Now, I want to show you a couple different ways here. I'm going to go through parts of the Tower of Power so you get an idea of what they're going for. So I'm just going to break it down. So, for instance, this is the first part of the Tower of Power. Again, your numbers will be different. But notice it says we're going to add using a place value chart. Because in this lesson, it's going to have you use a place value chart, and then it's going to have you do the standard algorithm. So it says show 4,328 in the place value chart. Use the fewest disks possible. And notice here, this is our equation that we're using. 4,328 plus 1,166. So first it wants me to create 4,328. Well, I just have to create how many thousands are in 4,328? There's 4. 1, 2, 3, 4. How many hundreds? There are 3. 1, 2, 3. How many tens? There are two tens. 1, 2. And how many ones? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. And then it says we're going to show 1,166 in the place value charts using the fewest as possible. So we're going to show the second number now. So how many thousands are in 1,166? There is 1,000. How many hundreds? There is 100. How many tens? Well, look in the tens place, there are 6. 1, 2, 3, 4, 5, 6. And how many ones? There are also 6 ones. 1, 2, 3, 4, 5, 6. Nice. All right. Now it's asking us, do we have enough ones to bundle? How many does it take to bundle? How many do we need to have to be able to bundle and move up one place value? If we think back, we need to have 10. We need to have 10 in any place value to bundle them and move them up. So it's asking us here, do we have enough ones to bundle? It's asking us, do we have at least 10? Do we have at least 10 that we can bundle? Well, let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 ones. So do I have enough ones to bundle? Do I have at least 10? Yes, I do, because I have 14. So I have at least 10. Okay, and then it wants me to bundle the ones. When it wants me to bundle, it just wants me to take 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're taking 10 of those, and we are going to move them to the tens place. Boop. So you notice how those 10 ones bundle together to become 110. Excellent. Do we have enough tens to bundle? So we're going to look and now see if we have at least 10 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do not, because I do not have at least 10 there. Okay. Because remember, you have to have at least 10. Do we have enough hundreds to bundle? 1, 2, 3, 4. No, I don't, because I need 10. And then I bet next it's going to ask me, do I have enough thousands to bundle? No, it didn't even ask me that. All right. So now it wants us to record the final answer in the algorithm. So now it wants us to solve it. Okay. And we've already actually solved it here, but let's see how that matches up. So if I go 8 plus 6, okay, 8 plus 6 here, what did I have? 8 plus 6 was 14. Remember, I had 14 ones, and right now I have 4 ones left over because I bundled 10 of those and moved them over. That's the same thing as carrying. Okay, you've probably been taught carry the 1. If it's 14, you carry that 1 over. It's the same idea. The bundling, that's what bundling is. Bundling is carrying. Okay, so then I go to my tens place. So how many tens do I have? I have 2 plus 6 plus 1, and I already have it all here. So that would be 9. Because you can look 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3 plus 1. So how many hundreds do I have? I have the 3 plus the 1. That was 4, because 3 plus 1 is 4. You can see it right there. And how many thousands did I have? I had 4, and then plus 1. Together, that was 5. Awesome. Now, if we're looking at this problem, it wants to say you solve using the algorithm. Algorithm is just the fancy way of saying an equation. So you're going to solve it just using our addition equation. So if I have 5,543 plus 1,191, okay, I already have this drawn up here. Notice when we add, right, we start with the lowest place value and we work our way up. So we're going to start in the ones place. And I just do 3 plus 1 is 4. Okay. I have 4 plus 9. 4 plus 9 is 13. Now, this is the same as when we saw it a moment ago and we bundled. Bundling is the same, like I said, as carrying. So if I have 13, I'm going to put the 3 down here, and I'm going to carry 1. Okay, I'm going to carry 1. Some you might have been taught to write it up above. Zern always has you write it below. It's kind of their thing. So 9 plus 4 is 13. So I had more than 10, so I carried 1. And then 5 plus 1 is 7. And then 5 plus 1 is 6. 6,734. And I'm just filling in what I did there. I did 3 plus 1 was 4. 9 plus 4 is 13. Carried the 1. Okay. 5 plus 1 was 7. And then 5 plus 1 was 6. And just to double check, 6,734. Yep. Good work. And the final part we need to be able to do in this lesson is make a tape diagram and then solve. We're not going to work through this whole problem together, but we do want to be, again, comfortable with what a tape diagram is. So a tape diagram, you're going to see, is just a way of drawing out and planning what you need to do. It's called tape diagram because it looks like a long piece of tape. And we can break it up into pieces. So for this one, it says, which tape diagram represents the problem? Okay. A painter has 28,483 milliliters of red paint, 27,383 milliliters of blue paint, and 20,876 milliliters of green paint to paint an entire house. How much paint does he use to paint the house? So it's an addition problem. It's asking us for the total. So it's asking us which tape diagram represents this problem. So when we have a tape diagram and we're dealing with addition, right, we have a whole and it's broken up into pieces. And all those pieces together give us the total. So, for instance, I'm just going to make one up here. If Billy had 3 apples, James had 2 apples, and Amanda had 6 apples, how many apples do they have in total? Well, you can see here that we have 3 pieces, and then the total is what we're trying to find. So we'd find the total by just adding up our 3 pieces. 3 plus 2 is 5. 6 would be 11. So in this case, this is a simple example. That's what that would look like. So in this case, we have these 3 numbers, and we don't know the total because that's what we're trying. How much paint does he use to paint the house? So what's their total? So which one of those has all 3 numbers represented in the tape diagram where we're trying to find the total? Well, if I look, it's not this one because we're missing a number. There's only 2 numbers represented here, where we had 3 up here. If I look at this one, this bottom one, well, it gives me 2 of the numbers in the tape diagram, but it puts the other one as the total. And it's saying, hey, we don't know what that third piece is, which is not correct. We know all 3 of the pieces in this problem. We don't know the total. So if we look at the second one, we have all 3 pieces represented. and then we're trying to find the total. So this tape diagram represents what this problem is asking. And then it asks us to solve that, and you would solve that by adding. We're not going to go through all that right now. That's what you will do when you get to it. But you get the idea of what it's looking for. So in this lesson, adding that extended addition problems. If you need assistance, you may let me know or your teacher.